O'Connell. I'm the founder and CEO of Canary Speech. At our core, we're a speech and language company specializing in identifying human condition and disease through speech. Canary Speech was founded about 5 years ago. The co-founders were Jeff Adams and myself, Henry O'Connell. Our history goes back many years, however. Jeff and I met in Washington, D.C. a little over 25 years ago. Jeff was working for the NSA, is a mathematician by training, and is a code breaker. It was during the Cold War, and Jeff spent a great deal of time developing models that would analyze encrypted messages and decode them. I was at the National Institutes of Health working in a neurology research group. Both of us spent about 5 years in those respective careers, and we moved on into a lifetime experience. For me personally, that meant working in the scientific field. I spent a lot of time in life science, managing companies, and over the last 18 years, I've been the CEO of a range of different companies doing turnarounds, always in the technology space. Jeff had a much cooler job at the NSA, which solidified and strengthened his position in the field with respect to creative ways of approaching modeling on complex data files and complex data sets. His job after the NSA was with a renowned scientist, Ray Kurzweil. And during that time, Jeff developed natural language processing. That led to Dragon Naturally Speaking, specialized language models in the medical field, and a range of medical dictation products that eventually became the company Nuance. During this time, Jeff was a major innovator and inventor in the field of speech and language. Before starting Canary Speech, one of the major things that he was engaged in doing was leading the team that developed the Amazon Echo. That required the creation and invention of a whole new field of speech, which we know today as far-field speech. Along with Jeff was a team of speech and language scientists and a patent lawyer, Jeff O'Neill. That group, forming the core of an expansive effort on the part of Amazon, has resulted in the launch of the Amazon Echo, among the more innovative products in the field. From that vast experience and the experience that we've had in disease and neurological function, Jeff and I decided that Canary Speech had an opportunity to create new technology that could benefit the field. Speech production is one of the fastest and most discrete human motor performances. It is a very complex source of data. We recognize the upper layer, the layer in which words are combined to form sentences and paragraphs and communicate meaning, often complex structures that allow us in hundreds of languages around the world to communicate one with another. One of the things that became obvious to Jeff and I in that first meeting was that in addition to the meaning of words, we're also communicating often our emotions in words. We can read excitement or stress or anxiety. We can read a whole range of different human emotions and conditions. And that led Jeff and I to believe that in the layers below speech, in the richness of those layers, we may also be able to extract information concerning both human condition and disease. We asked ourselves, how can we understand emotion from simple conversation? One of the examples I often give is that of being a father. My wife and I have 5 children. They're grown now. They have their own homes. They have their own marriages that they're managing. They have a young family gathering around them. And any given day, I don't have the same contact with my children that I had when they were living home. I can't watch my daughter come home from middle school and striding across the room. I can recognize from her gait or from her physical cues whether it was a good day or a bad day, and I'm engaging with her based on cues that I'm reading. Now, I don't have that same connection to the physical cues in the environment. When I would call her, one of the things that I have noticed in a simple phone call, within moments of starting that conversation, I understand whether it's been a good day or a difficult day, whether she's anxious or she's nervous or she's excited or she's happy or she's sad. And it has literally nothing to do with the words that she was speaking. And I assure you, it's irritatingly accurate. From that, we asked ourselves a simple question. How are we accomplishing that? If it's not the words and we're detached from the physical cues in the environment, her gait, her facial expressions, a range of different things that might indicate to us a deeper meaning beyond the words that she is speaking, I'm also picking up on a range of different human conditions. So Jeff and I decided that we would explore in a practical and scientific way the information that's buried in the layers below the surface of speech and language. So our technology approached capturing critical information that could provide accurate and reliable assessments on both mental, behavioral health data, things like depression and stress, anxiety, but also on our cognitive functions. Are we thinking clearly today? Is our cognitive function impaired in some way because of what's going on with our lives? We wanted to replace subjective measurements that are used across the medical industry with objective assessments based on an array of data that could be found in speech. We felt if we could provide that kind of assessment and that it had definitive information longitudinally about either an individual or a population, it could be gathered in simple conversational speech in a non-invasive way, that could provide a real value to both the medical industry and also to health and wellness. We found that these elements were language agnostic. They're more closely attached to how the central nervous system creates language than they are the language itself. We use these diagnostic tools, features in speech or biomarkers, to provide assessments that allow us then to measure a whole range of human conditions. Early on, we were engaged with a client that provided us with the opportunity to do assessment in the Alzheimer's disease market area, or to work with Alzheimer's patients and to assess conversational speech and to provide an opportunity through feature extraction and specific models to assess Alzheimer's and their conditions. What we found within the Alzheimer's patients was a rich set of features that could be used to construct an algorithm or a model. And then we could use that model in assessing Alzheimer's patients from which we didn't have any prior knowledge. This provided us with a ground-breaking set of work that demonstrated that speech could be used to provide accurate, rapid assessments on as little as 2 to 3 minutes of conversational speech, and do that across populations. What we found were biomarkers in speech below the level of words, 2,548 specific markers. We use a 20 millisecond frame and collect samples on all 2,548 biomarkers within that frame. We slide the frame 10 milliseconds and do the same. So we create a data collection of overlapping frames of all 2,548 markers. From those, we use guided machine learning to extract features that correlate in double-blind studies with the labels that are attached to the diagnosis of specific disease. We employ or deploy the gold standards to diagnose both the condition, the presence of a condition, such as stress or anxiety, using GAD-7 or STAY, using the Montreal Protocol for the Alzheimer's test, or the MADRS test for depression. We use those gold standards with clinicians to assess the level and severity of disease, and then we extract features that correlate to that. And from those features, we build models. Those models have then been trained specifically to recognize a range of different linguistic, paralinguistic, and voice features that allow us to target and identify specific diseases across populations. Once those models have been built, we can deploy them on smart devices, capturing a few minutes of conversational speech. We can provide individuals and their clinical teams with assessments on these conditions that are non-invasive, easy and rapid to collect and deploy, and scores that are reproducible and accurate. Historically, approaches in the field, going back as much as 20 years, have been to analyze this upper layer of speech, to look at word patterns and the use of words and gaps between words, to look at tonal qualities and in those words and the text analysis. That offered some foundational and important work that demonstrated that speech and human condition and disease were in fact connected, and that you could do assessments, but the assessments were relatively rough or gruff. They dealt with the patterns of words, the lack of words, and those things often depend on a range of different things we have difficulty controlling for. In our approach, by using biomarkers that are in the layers below the actual words, we're able then to extract and train models and use those models in practical ways in clinics, in clinical studies, and even in health and wellness applications. Canary Speech has developed the capacity now to capture through smart devices using Android and Apple phones or tablets to capture audio and then to provide assessments that can return a score within 3 seconds of time, either to the user or to a clinical team. That means that we've taken the technology to a point where it's functioning in near real time, which makes it practical and useful in a range of different environments. So just to review, Canary Speech looks at linguistic and paralinguistic features. We're looking at the voice quality features such as jitter and shimmer and a whole range. But we also look at the spectral characteristics. We look at harmonics and noise ratios. We look at a range of different types of characteristics within speech, the entropy in speech, the energy in speech. We study and record a range of different first, second, and third order derivatives. So we understand within that window, that 10 millisecond window, we understand what's happening. We slide, take the same measurements, and slide and take the same measurements. This allows us, as I have said earlier, to build models that then can be deployed in a practical um, and reliable way to measure and reproducibly uh, produce accurate scores on a range of different diseases. What we've also found is during that same 3-minute sample, we're able to assess, let's say, for instance, we're looking at Alzheimer's. We're also able to assess the comorbidities that may be related and associated with the disease, such as stress, anxiety, or tiredness. So while we're looking at the presence of Alzheimer's and the severity of it, we may also look at specific function or elements such as stress or anxiety, providing a much richer source of information to the individual and to the clinical team providing care. Canary Speech sought through the patent system to demonstrate both our uniqueness and to create certain protections for the company for what we believed was a novel approach. Canary has been issued 6 U.S. And European patents, 4 in the U.S. and 2 in Europe. Our initial patents covering our core technology and the approach that we have received 100% of their claims, both in the US and in Europe. Those patents are pending now in Asia. The other patents have to deal with the use of conversational speech and smart devices for the analysis of this, making it practical and deployable in environments where we can provide a rich source of information which is actionable by either a clinical team or an individual managing their own health. Canary Speech understood very early, going back 5 years, we engaged in doing a range of different validation studies, double-blind studies working within FDA phase 2, phase 3 trials, as well as some phase 0 studies that are IRB approved. We recognized that we needed to build a bridge between the use of speech and language technology and the current gold standards that are accepted and used every day, hundreds of thousands and millions of times really, throughout the world. It was important to demonstrate the validity of speech and language as a technology that could provide accurate information and do so in a manner that could be more accessible to a whole range of populations. Imagine the impact on telemedicine and rural health and expanding the capacity of a healthcare organization to reach the rural centers and connect them to the hospitals that may be remote by 100 miles or more. This provides the opportunity to gather information in an accurate way from populations that are remote from clinical care. Canary Speech today is functioning in English. We have run projects in both the US, Canada, Japan. We're active right now in Europe and Ireland, and we have projects planned for mainland and rural China in Mandarin Chinese. The application of speech and language technology has a substantial opportunity to improve the quality of care and to reach people who are, at this time, often remote from care.
Hi, I'm Caitlin Brooksby. I'm the Executive Director of Communications and Marketing at Canary Speech.
You know, as Henry mentioned, we're 5 years old. We had done work in Japan. We are operating in Japanese, but we really wanted to decide, where are we going to go? And what I'm going to explain is how really naturally we were taken to Europe through the people we met and the connections. And I think it's interesting because I really feel like that's how things develop. We had a strategy, we had a plan, but really the people who we met were just integral to where we are right now, 6-7 months later. So starting out, here's a timeline. In August, Henry spoke at Harvard Medical School. He was presenting on Canary Speech, and he met Gavin O'Duffy. Gavin is he's over Europe at Amazon in the technology area based out of Dublin. And Gavin and Henry just hit it off naturally. Henry wouldn't mention this, but Henry is 100% Irish. His grandparents are on both sides, are both from Ireland, and so they really got along. And Gavin introduced us to a few critical people who we just really all have gone along so well, and that is a group at Tala Hospital. We met Dr. Sean. He's a very intelligent man. He is a consultant physician in geriatric and stroke medicine. He's the director of memory assessment and support service. He's head of Department of Age-Related Healthcare at Tala University Hospital. And he's a clinical associate professor of medical gerontology at Trinity. So very intelligent man. And he's been doing studies around gait. So watching and studying how people walk and what does it indicate about their health. And so we flew out to Dublin in October, and back when we could travel. And it was just so fun to meet with them. And so now currently we're underway with putting together a protocol for an Alzheimer's study, which will include 200 patients over about 6 to 8 months. And with COVID, we did have to put it on hold. I think many of you have probably seen this in your own business where certain projects had to be put on hold due to COVID-19, but yet other opportunities have come along. Move ahead to January. So in January, we met Michael McTeer from Ulster University. We actually met him in Chattanooga, Tennessee, of all places. We met him at a voice conference there, and Michael and I and our team, we got along, and Michael introduced us to his colleagues. I want to tell you who Michael is. He is a professor of knowledge engineering at Ulster, and so we got in conversations with his colleagues over at Ulster University, and they introduced us to a project that they're a partner on, which is a WHO sponsored project. It's called H2020 Research and Innovation Staff Exchange, and it's mental health monitoring through interactive conversations. So this is a 4 to 8 year project of just research and developing conversational technologies to promote mental health. And we are so excited because we are joining some of the greatest universities and organizations around the world to study and really try to understand behavioral health using speech and other technologies. And so we are so excited to be joining this project. So we go back to our Trailblazing speech recognition timeline here. We really, as I pointed out, we met just these critical individuals who have introduced us to exciting projects that they're doing, and really us joining in and adding speech technology. And then the final area that I want to go over, as I mentioned, though some projects and studies have had to be put on hold, we also are starting a new speech analysis project for COVID-19. We can't get into too many specifics yet, but it is going to be in the EU and involving really some cool universities that have done amazing things and for centuries. And COVID-19 is just that next phase for us. And so this is really just our last 6, 7, 8 months of us entering Europe and what has come about. And so I'm excited to share that with you. And I hope that as you guys look to, expanding your international relations and entering new areas, that really finding those key people is what's going to open the doors. And that's what we found for ourselves. So thank you for taking time of learning about Canary speech, seeing how we've really entered Europe and what we plan to do over the next 6 to 12 months. And hopefully we'll have an update for you guys later. Thanks so much.